Welcome to the KuppingerCole Analyst Chat. I'm your host. My name is Matthias Reinwarth. I'm an analyst and advisor at KuppingerCole Analysts. In each edition, I will have one guest joining me, often a fellow analyst or another interesting partner, and we will have a 15 minutes or so chat around current topics. My guest today is Alexei Balaganski. He's also an analyst at KuppingerCole. Hi, Alexei.
Hello, Matthias. Thanks for inviting me again.
Great to have you again. And our topic today is really an interesting one. And I think that is a topic that many organizations are currently talking about. We'll be talking about the SOC, the Security Operations Center, and all the technologies or some of the technologies behind that. So I think that's a good starting point. Alexei, for a first definition, how would you define an SOC?
Well, I really first like to address the actual topic of our episode today. It's called the alphabet soup of security analytics. And it's really the biggest challenge we are having now as analysts when talking to customers or to vendors, that everyone has a different understanding of what a particular letter combination actually means. Be it SOC or SIEM or SIP or SOAR, you have so many new acronyms to learn, and it doesn't actually add anything useful to the discussion. It only confuses a lot of people. So the goal of our discussion today is to make a little bit of sense of this alphabet soup. But you're absolutely right. We have to start not with a tool or a solution. We have to start with a challenge. And the challenge for a modern digital enterprise is just to stay on top of everything security related which happens in that enterprise. And for that, the usual approach is to establish a security operations center, which might be a physical location with a team of your own employees, or it might be a cloud-based solution platform, or even a managed service where you basically just rent a team of experts with their own security operations center. But the whole point of it is you collect all the events, all the security relevant information of anything that happens across your infrastructure in that particular place, somehow, in a solution, let's say for the moment. And then you let your experts to sift through all this information, identify current or potential threats, and hopefully mitigate those threats. And again, let me stress it that Security Operations Center, the SOC, is the only acronym that matters. How exactly you build it is a secondary question.
Okay, understood. But nevertheless, you mentioned the alphabet soup, and if I'm right, the first term that you mentioned already, and that is involved here, is a technology that is already some time around, and that would be the SIEM.
Exactly, the SIEM, Security Information and Event Management. If I remember correctly, this acronym is already 15 years old as of 2020. It was introduced 15 years ago as the ultimate solution to all of enterprise security problems. And the idea was that instead of having to use lots of different disjointed tools like an antivirus or a firewall or intrusion detection system to consult separately, you just let all of those tools feed their data into a single database. And that database would be your SIEM, your Security Information Management. And on top of that, you would run some kind of a rules engine or a filter or a search solution to allow your analysts to find relevant events and maybe even produce some security-related alerts. And that would be your SEM, so the Security Event Management. And together they formed a SIEM. And a SIEM is, until now, is probably the most popular technology which powers a security operations center. Although, of course, it's no longer the only one.
Right. But if I think in a very naive manner, if I gather all the information from all the systems that provide relevant information that could be integrated into such a solution, we end up with an immense mass of data, which is almost impossible really to filter or to analyze without any additional help.
Exactly. And this is exactly what people have realized probably a year or two after the initial SIEMs appeared on the market. So first of all, a SIEM is a traditional SIEM solution, which would be a huge database running on an on-prem server farm and so on. It's extremely complicated to set up. it's extremely difficult to customize to a specific network and infrastructure of a specific company. It requires a team of experts to just operate, not even to use, just to operate, to maintain it in a running state, if you will. And of course, it collects huge amounts of data without making any difference between relevant and irrelevant data. And we all know that irrelevant, the statistical noise would probably be 99.99% of all that collected data. And in a typical SIEM or in a modern large enterprise, you end up with tens of thousands of alerts, even with all the carefully crafted rules in place, because the total number of events collected through a day would be in millions. So, of course, if you have 10,000 alerts a day, even your largest team of the best experts just have no time to react to all those events. And that was probably like the single biggest challenge, is what we would now call a legacy SIEM.
Are SIEMs in that form still a thing for Security Operations Center? Is this really something that is used as of now?
Well, let's use my favorite German word, jein. So yes and no. A SIEM, of course, is still relevant. But a modern SIEM is by far no longer that SIEM that used to be 15 years ago. And if we look, well, at least if we here in our studio look at a brief history of SIEM, and I can tell you that it involves at least 4 major generations over the last 15 years. So that first generation of SIEMs even predates the cloud, because the first public cloud appeared a year after the first SIEM. And of course, they predate the still popular notion of big data. So basically, just about 5 or 6 years after the first generation of SIEMs, we already had the second one, the major improvement, because they were already running on our big data frameworks instead of classical databases. They were able to be deployed in a cloud infrastructure, so they were immensely more scalable and did not require that much operational effort. But still, they were largely rule-based. So basically, in order to configure your SIEM to alert you on a threat, you first have to know about the threat. And then you would have to be able to craft a number of rules relevant for that threat. So basically, that second generation SIEM, while much more performant and easy to operate, was still very much like a classical antivirus. It was quote-unquote signature-based SIEM.
Right. So the actual problem that you described for the initial SIEM versions was still not really cured because this signal noise ratio was, which was not good, was still in existence, but at a big data scale.
Yes. So the second generation SIEMs were able to collect now probably billions of events, but they will still end up generating millions of alerts.
Right. So it was just sizing up the problem.
Yeah. So kind of extensive evolution didn't quite work out for SIEMs of that second generation. However, we had a major breakthrough in the machine learning and artificial intelligence just a couple of years later. On the chart, which I've prepared some time earlier for a presentation, there is a flag for the year 2014, which probably was the major breakthrough in commoditizing machine learning. The technology, which was previously only available to owners of extremely expensive mainframe systems, now was running in the cloud, and everyone could train their own machine learning models and do something useful with it. And of course, we know that machine learning is extremely useful in looking for patterns in data on one hand, and looking for outliers, for anomalies in the same data on the other hand. And that was extremely useful even without creating a specific threat-related model. You just could use the general purpose machine learning algorithm to reduce like at least 95% of that statistical noise, and reduce the number of alerts from thousands to maybe dozens, which alone was a huge improvement. At least now it was manageable for a human team. However, I would say the most important feature of that third generation SIEM, if you will, what we used to call real-time security intelligence platforms, is that they were intelligent indeed and real-time. So they were fast enough to not just sift through historical data, but to react to incoming security events in real time, apply some smart correlation algorithm, and most importantly, they were able to apply a threat model to the data. So instead of having a flat list of security alerts, you would have a very colorful and enriched list of incidents ranked by a risk score, a criticality level, enriched with some additional information relevant for forensic analysis. So basically, instead of looking at a flat list of even a dozen alerts, you would immediately know where to start, because the one on top would be the most relevant for you to deal with.
Okay, great. So that means that this third generation of SOC tools was capable of, on the one hand, filtering the data, so getting down to a list of items that could be dealt with, and it even did some pre-filtering, some pre-assessment based on the criticality of the events. So it really was of help for the actual security analysts at work.
Absolutely. And most importantly, it did not require you to write rules. So yes, modern SIEMs still rely on rules to a substantial extent. And when you buy a SIEM nowadays, even from a large enterprise vendor like, say, IBM, it comes with a huge packs of rules. But the beauty of a real-time security intelligence platform, the RTSI, or as some vendors call it now, SIP, Security Intelligence Platform, in that they do not rely on rules. So they are able to react to previously unknown threats, especially if those models which they are built around are looking for behavior aspects of security events. They're not just looking, say, for example, for the fact that a file on your server is suddenly encrypted, which might be a sign of ransomware attack, but it might be something else. But they would observe it in time, and they would see, for example, that 100 files on your file server are being encrypted one after another, and that has never happened before. That is a behavioral anomaly. That is a reason to raise a highly risky incident for your analysis, so to say. So this combination of no need for rules anymore and for incorporating behavior analytics, that was probably the single biggest breakthrough in SIEM evolution.
Okay, does this also consume external information about threats? So information that is provided by third-party providers of such information?
Of course. And again, that threat intelligence feed, the notion is old, but the meaning has evolved. 20 years ago, there were probably already some providers who would give you a list of known malicious domain names, for example, or IPs of command and control centers, or known compromised file hashes. This is also threat intelligence. This is still useful and relevant. But what we have now, for example, we have the cognitive security platforms like IBM Watson, for example. Those platforms are really powered by the, again, quote unquote, next generation AI technology, the cognitive systems which go through previously unreachable information, the dark web forums, academic research libraries, online sites where hackers or security analysts discuss their recent discoveries and so on. And all this is being converted by a huge cloud-based brain, if you will, into threat intelligence which can be consumed by modern SIEM solutions.
Okay, so we have learned in other podcasts that the attackers are using technology and they are using automation to increase the volume and the sheer power of their attacks through automation. So now we see that the operators of SOCs that are based on these technologies can counter this with automation again. So we see machines fighting against machines?
Exactly. And it's not just any kind of automation, because to be honest, like scripting is also automation. But this is intelligent automation. And again, it's some kind of automation which, first of all, does not require you to write a rule for everything. If a tool gives you a possibility to describe your security measures in a prescriptive manner, that lets you define a policy instead of a rule, that alone simplifies your job as a security specialist immensely. But if the same technology helps you to automate your response to the discovered problem, or at least to automate the additional forensic analytics, and will only give you the final decision to make with one button click, that is a huge productivity boost to security analysts in a SOC. And that would be the final acronym for today, SOAR, Security, Orchestration, Automation, and Response. This is probably the hottest recent development in the security analytics market nowadays. The first solutions appeared just a couple of years ago. Now they are constantly evolving, and some of those are finding their way directly into existing SIEM solutions. So basically, you are now witnessing the emergence of the fourth generation of SIEMs, those which actually combine all those acronyms, so the SOAR, the SIP, the UBA, the machine learning and AI, and so on, and add additional incident response capabilities. But they still prefer to call themselves a SIEM 4.0, if you will, a next generation SIEM, a smarter SIEM. It's just like an antivirus. The anti-malware solution today is nothing like the antivirus of 20 years ago, but the notion still sticks.
Okay, and it still is a term, the SIEM, that people are used to. So if we now look at what organizations should be looking for when they try to acquire such a solution, where would they start? How do they get the best of all worlds that you described already?
Well, again, it's worth noting that the first thing that organizations should do is stop looking for acronyms, stop playing the alphabet soup game, and start looking for capabilities. And those capabilities could probably be broadly classified in three major aspects. One would be increasing the productivity of such a solution. And this involves primarily consolidating all those previously disjointed security sources and security tools in one place. So no longer you just kind of run your SOC on top of your log management solution. No, your SOC should be able to consume real-time security data from the cloud services. Maybe have API connectors to embedded systems. Work with your endpoint security solutions to kind of share that crowd wisdom in both ways. But most importantly, it has to be flexible and open and allow for quickly adding new sources of that security data. It should provide your analysts kind of rich collaboration capabilities, because one person is already far behind in intelligence and agility, if you will, to work on a serious security incident. It's always be a teamwork, and that team should be able to efficiently collaborate. And of course, it has to be orchestrated and automated as much as possible, as we just discussed. So those security tools should be able to work together if they can. If they are not smart enough, there should be some kind of a scripting or playbook kind of automation which manipulates them for you, for your human analyst. So ideally, the goal is to give your security analyst a one-button decision capability. One screen to show all the relevant information, some decision support based from previous experience or from kind of crowd wisdom or even from the AI engine like Watson, and just a button, fix it for me. That's kind of the ideal goal for the future. And of course, this is where the next aspect of your next SIEM comes into play, its level of intelligence. So yes, everyone is talking about AI, machine learning, cognitive technologies nowadays. And of course, every SIEM product nowadays comes with an AI-powered label on the box. But you have to understand that not every AI is equally smart. Some of those products probably don't even use machine learning at all. They are still relying on the old and trusted statistical method of data correlation, which works absolutely fine if your data is simple enough and kind of clear enough to be processed in that way. But again, that alone is by far not enough. So you should be looking for more advanced capabilities. The cognitive technologies I mentioned earlier, how to unlock the unstructured security data and how to convert it into something machine readable. How to look for correlations with your past experiences. Like if, for example, a similar security event has already happened multiple times in the past, you already have a profile of your own decisions. Why not just kind of ask the AI assistant to suggest you the best decision based on that history? You should be looking again for intelligent automation, so automation which is not rigidly rule-based or script-based, but can be automatically adapted to new types of security data, to new threats, to new types of security tools, and so on. And of course, the ultimate goal, as I mentioned, is the holy grail of cybersecurity, the autonomous threat mitigation. Some people are still extremely scared about the possibility, especially if we are talking about like operational technology networks, where some slight misconfiguration or blocking out a sensor can lead to a catastrophe. But even those old school hardcore OT engineers are already opening up to some levels of security automation because it saves so much time.
I got it. So as we're getting close to the end of this podcast episode, and I'm sure that we have to catch up on that topic again in a later episode, I understand that you are really the expert here. When people are trying to inform themselves, learn more about that topic, I assume there's research at KuppingerCole that they can look for and to learn more about the technologies behind that and also about actual products implementing that?
Well, of course, this is one of the topics which we have quite a lot of coverage, both for individual solutions. So obviously on our website, you will find the executive view kind of reports of individual SIEM and related solutions. We're currently working on our leadership compass, so a multi-vendor comparison for security automation solutions, which will be released sometime later this year. Let's not commit to a deadline yet. But again, we can also provide you lots of visual kind of information just to study at your own pace. So our past and upcoming webinars, presentations, or just talk to us. We are open to all kinds of discussions and possibilities.
Great, thank you. And I think there will be a virtual event coming up later in June, I assume, which will be focused on cybersecurity. And actually, we hope that we can run our Cybersecurity Leadership Summit in Berlin in November. That is something that we're currently planning and that we're looking forward to. And we hope that this can happen then again. So, Alexei, thank you very much for your explanations in that area. I know there is much more in that topic available for us, so we will catch up on that and learn more about the most recent developments here. For the time being, thank you very much, Alexei, for joining me here today. Any final words from your side?
Well, first of all, thanks for having me again. This is really one of my favorite topics. I could probably talk about it for hours. Unfortunately, we are limited on time, but again, we are open to one-on-one discussions with any potential, well, let's not call them customers, but kind of any people who are looking for assistance and advice in that regard. And again, thanks a lot to our audience. Stay safe, stay healthy, and see you in a future episode.
Nothing to add from my side. Thank you very much, Alexei. Bye-bye. Thanks to the audience.